Hi, everyone. Welcome back to Learn With Me. I'm Deborah Hanson, and today we're going to be breaking down the course exam description booklet, better known as the CED, to help you navigate all the information you need to know to get a 5 on the AP exam. So today we're going to kick off with Unit 1 of AP Human Geography, also known as AP HUG, Introduction to Maps and Types of Maps. And this is where it all begins, and understanding these basics will help you make sense of everything else in this course. So before we get started, let me explain to you how I do this. I break down the CED. I look at all the CED questions. I give you all the essential knowledge you need to be able to answer those questions. We know that the College Board bases the exam on the CED. That's why it's called the Course Exam Description Booklet, right? So they're going to take everything in there and they're going to create the exam. So understanding how to answer all those questions, understanding everything you need to know is the key to the 5. So let's get started. So I really believe that understanding and knowing your key terms for all APs. I mean, I do AP Psych, I do AP Bio, AP World, AP US History. I do a lot of these AP courses, but the key terms are really the key to the 5. And that's knowing your key terms, not only just the definition, but examples of it and how to apply it to the questions, especially with MCQs when you have to make a choice that matches the stimulus. If you don't know the definition or you don't have an example in your mind, you're going to have a harder time answering that question. Same with your FRQs. So very important to know your key terms. Now, I always make a separate video with just key terms, and I go through each of the key terms on this list, example and description, definition, so that you can learn them. And I always recommend you do flashcards. I know some people are more techie. They prefer to use Quizlet or sort of a digital type of doing, learning those. And again, you got to do you, right? So if you learn best digitally, then find a way that is going to help you learn those key terms. If you're kind of like me, old school, I like flashcards. I like especially the ones that are ring bound so I can keep them all together. That's what you have to do. But whatever you do, you have to know your key terms. So the CED question for 1.1 of AP Geography Introduction to Maps and Types of Maps is this. Identify types of maps, the types of information presented in maps, and different kinds of spatial patterns and relationships portrayed in maps. So for Unit 1.1, you need to be able to identify all the different types of maps. You need to be able to understand what information they're showing you. You also need to be able to explain how map scale and projections work and how they affect the way we see the world. So finally, you'll be looking at patterns in spatial relationships like distance, direction, and distribution. Let's get started. So as I was saying, key terms are important. So throughout this video, we're going to be looking at definitions of the different key terms that are important for you to know for test day. And that is the key to the 5. I always say key terms are the key to the 5. So let's start with maps. Maps are tools that geographers use to show places on Earth. They use symbols and colors to represent things like cities, landforms, and roads. More importantly, they help us study spatial patterns and how places and things are arranged on the Earth's surface. Now, you're going to see out throughout the video that I kind of have just basic information on these slides. If you want the full slideshow, the booklet that goes with it, everything, please just check below to the link to my Teacher Pay Teacher Store where you can actually get the whole set, the notes, the videos, everything, and I should have those up really soon. Now let's talk about reference maps. These are general purpose maps that show locations of places and geographic features. They're used for navigation and locating physical and cultural features on the Earth's surface. These maps don't just focus on data or themes, but instead they help users understand where things are and how places are arranged spatially. There are different types of reference maps. For example, you have political maps, and these show boundaries between countries, states, and cities. You have physical maps. They show natural features like mountains, rivers, and elevation. We have road maps. They show highways, streets, and transportation routes. Or plat maps. They show property lines and land ownership. Why does this all matter for the exam? The College Board may ask you to identify or compare map types, especially when analyzing using spatial data. You should be able to explain that reference maps display physical and cultural features clearly, unlike thematic maps, which are focused on data patterns and like population or income. Now, thematic maps are different from reference maps because they focus on specific types of information or data. They're tied to a particular theme or topic. These maps help geographers and data analysts understand spatial patterns, trends, and relationships in a geographic area. So, types of thematic maps include Choropleth maps, and they use shading or colors to represent quantitative data like population density, literacy rates, or election results across regions, for example, states or countries. Dot distribution maps use dots to represent frequency or concentration of something. For example, one dot equals 100 people. These help show clusters or spread of phenomena like disease outbreaks or fast food restaurants, just as examples. Other common thematic maps, optional for the sort of more AP students and sometimes on the exam, graduated symbol maps. They use symbols of different sizes to show quantity. Isoline maps, they use lines to show areas of equal value, such as elevation or temperature. And cartogram maps, they distort land area to represent data like population or GDP. Here's your exam tip. The AP exam may show you one of these maps and ask you to interpret patterns, analyze spatial distribution, or compare them to reference maps. Make sure you can recognize the map and type and explain what kind of data is being represented. Let's just take a look at a few more types of thematic maps. For example, graduated symbol maps use symbols of different sizes like circles or squares to represent different quantities or amounts of something in a location. The larger the symbol, the greater the value it represents. So, for example, a map showing COVID-19 cases might use larger circles for cities with more cases. A map of earthquake magnitude could use varying size symbols to show the strength of each quake. These maps make it easy to compare relative values across places, but overlapping symbols can make them harder to read in a densely populated area. Here's an exam tip. Know that graduated symbol maps combine locations and amount in one visual. You may be asked to analyze where the largest or smallest values are concentrated and why that pattern might occur. Isoline maps can connect points of equal value using continuous lines, kind of like a connect the dot map for data. These maps are used to show gradual changes across space. For common examples would be topographic maps. They show elevation. The closer the lines, the steeper the terrain. Weather maps. They use isotherms for temperature and isobars for air pressure. These maps are great for showing gradual transitions and spatial trends in things like climate, air pressure, and pollution levels. Here's an exam tip. Isoline maps are especially helpful when describing how and where change happens over space, not just where data is located. Now, cartogram maps distort the size and shape of geographic areas, like countries or states, based on specific statistics instead of actual land areas. Common examples: a cartogram showing population will make countries like India and China appear larger than countries with more land but fewer people. A cartogram showing GDP might enlarge wealthy countries and shrink poorer ones. These maps are visually striking and help highlight patterns and comparisons really quickly. Here's an exam tip. If a question asks about visualizing spatial inequality, distribution, or relative importance, cartograms are a great choice. So remember earlier when we were talking about the CED question, they were talking about map scale as well. So map scale tells us how distance on a map relates to distance in the real world. It helps us understand how much the real world has been reduced to fit on the map. So three main types of scale. One, ratio fractional scale. So for example, one, and then you'll see the colon to 1,000, which means 1 unit on the map equals 100,000 units in real life. Written or verbal scale, for example, 1 inch equals 1 mile. So easy to understand, easy to read. Graphic bar scale, a visual line that shows real world distances, useful when printing or zooming changes like on a map size. So why does it matter? Scale influences how much detail we can see. Large-scale maps show small areas in detail, like neighborhoods, while small-scale maps show larger areas with less detail, like continents or countries. Now let's move on to projections, how we turn the 3D Earth into a flat map. Every projection distorts something, whether it's shape, size, or direction. Projection is transferring locations on the Earth's surface to a flat map. So depending on what the cartographer wants to focus on, when they have 4 choices to make, they have to make sure that the globe fits on the paper. So the shape of an area can be distorted, the distance between 2 areas could be inaccurate, the relative size of different areas is inaccurate, or direction can be distorted. We're first going to take a look at the Robinson projection. The Robinson projection is a compromise map projection designed to create visually appealing world maps. It attempts to minimize distortion in all four key areas: shape, size, distance, and direction, though none are perfectly accurate. This projection curves the edges of the map, which helps keep continents more proportionally sized, especially at higher latitudes. Polar regions are flattened, but not as exaggerated as in the Mercator projection, which we're going to talk about later. Because of its balanced appearance, the Robinson projection is commonly used in textbooks, classrooms, and atlases. You should recognize that the Robinson projection is used when the goal is to present the entire world in a way that looks right, not for navigation or data precision. It's often used to display spatial patterns in a way that's easy to interpret visually. Next, we're going to look at the Mercator projection, which keeps directions accurate, which is great for navigation, but it really distorts the size of countries near the poles. So here we go. The Mercator projection is a cylindrical map projection developed in the 16th century by Gerardus, oh my goodness, I'm having a hard time saying it, Gerardus Mercator. Hence the name Mercator projection. It is designed to preserve direction and shape, making it feel like ideal for navigation, especially for sea travel, because straight lines on this map represent constant compass bearings or rhumb lines. However, it greatly distorts size and area, especially as you move closer to the poles. For example, Greenland appears similar in size to Africa, even though Africa is about 14 times larger. The distortion leads to Eurocentrism, as European and North American countries appear much larger than they actually are. So use the Mercator projection when you're being asked about navigation, directional accuracy, or historical uses in exploration. But remember to critically evaluate its distortion of spatial perspective, especially for area comparisons and global influence perceptions. Okay, next we're going to look at Peters projection. The Peters projection is an equal area map projection, meaning it accurately represents the relative size or area of land masses. Unlike the Mercator projection, it does not exaggerate the size of countries near the poles, making it useful for showing true proportional relationships between regions. However, to maintain equal area, it distorts the shapes of continents and countries, making them appear longer or kind of squished, especially near the equator and poles. The projection was introduced by Arno Peters in the 1970s and sparked debate for challenging the dominance of the Mercator map. So why does this matter in AP Hug? The Peters projection is useful when discussing spatial equality and how maps can reflect cultural or political bias. It's often used by organizations that want to emphasize fairness in geographic representation, especially between the global north and the global south. The last projection we're going to talk about is conic projection. A conic projection is created by projecting the Earth's surface onto a cone placed over part of the globe. It is most accurate along the standard parallels where the cone touches the Earth. This type of map projection is best suited for mid-latitude regions like the US, Europe, or China, because it minimizes distortion in those zones. Conic projections typically preserve shape and distance well over small areas, but distort size and directions towards the outer edges. It's commonly used in climate maps, aeronautical charts, and regional road maps in the US. Why does this matter for AP Hug? Conic projections are ideal when geographers need regional accuracy, especially when focusing on east-west oriented areas. Understanding which projection is best for a specific use helps explain how geographers display and analyze spatial data. That will be asked on the AP exam somewhere. So you need to know your projections for the test. Now let's talk about grid patterns. A grid pattern is an urban layout where streets intersect at right angles, forming squares or rectangles. This design is common in planned cities, especially in the United States. So like New York City, Chicago, Phoenix, you'll find these grid patterns. Grid systems make it easy to navigate, organize property, and plan infrastructure like roads, utilities, public spaces. They're especially effective for efficient land division, zoning, and real estate development. Why does it matter in AP Hug? Grid patterns reflect urban planning strategies and can reveal how a city was developed, planned versus organic growth. They're linked to colonial influences, especially in Latin America and the US, where Spanish or American planners used them. And studying grid patterns helps students understand how human behavior shapes the landscape and how transportation and economic systems function in urban environments. No geography would be complete without talking about latitude and longitude, so let's talk about that. Latitude lines run horizontally, east to west, around the globe and measure how far north or south a place is from the equator at 0 degrees latitude. They range from 0 degrees at the equator to 90 degrees at the north and south poles. Major lines of latitude include the Tropic of Cancer at 23.5 degrees north, the Tropic of Capricorn at 23.5 degrees south, the Arctic Circle at 66.5 degrees north, and Antarctic Circle at 66.5 degrees south. Now let's talk about longitude lines. They're also called meridians, and they run vertically from North Pole to South Pole and measure how far east or west a place is from the prime meridian, 0 degrees longitude. They range from 0 degrees to 180 degrees east and west. The international date line is at 180 degrees longitude, and it marks the point where calendar dates change. Important notes for the AP exam: latitude influences climate. Closer to the equator, warmer. Closer to the poles, colder. Longitude is crucial for understanding time zones and navigation. And lastly, together, latitude and longitude form a global grid system used to identify precise positions on the Earth. Another key term you need to know for AP Human Geo is absolute location. The definition is absolute location is the exact spot where something is found on Earth. It's identified using latitude and longitude. Here's an example. New York City's absolute location is 40.712 degrees north, 74.0060 degrees west. This tells you exactly where it is, no matter who you are or where you're coming from. This matters in AP Human Geo because absolute location helps geographers map and analyze spatial data. It's used in GPS, navigation, and mapping software. It differs from relative location, which describes a place in relation to something else. So, for example, something that is next to the river or next to the mountain or something like that. So a quick tip for the exam: if a question asks about specific precision or coordinates, they're referring to absolute location. Let's talk about meridians or longitude. The definition is meridians are vertical lines that run from North Pole to South Pole. They measure how far east or west a place is from the prime meridian, the 0 degrees longitude, which passes through Greenwich, England. Each meridian is numbered from 0 degrees to 180 degrees going east and west. Why does it matter? Meridians are used to calculate absolute location paired with latitude. They help define time zones, and they're important for navigation and mapping east to west distances. Here's an AP tip. If a question mentions east-west measurement, prime meridian, or vertical lines, it's asking about longitude meridians. Now, absolute distance. The definition is absolute distance is the exact physical space between two places. It's measured using standard units like miles, kilometers, or meters. For example, if the distance from New York City to Washington, D.C. is 225 miles, that number is the absolute distance. Why does it matter? It helps geographers compare space between places. So it's used for mapping, transportation planning, understanding spatial relationships. Here's a key point. Absolute distance is fixed and does not change based on time, effort, or cost, just the actual measurement on Earth. So we just talked about absolute distance. Now let's look at relative distance. The definition is relative distance describes how far apart places feel based on travel time, cost, or effort, not just physical spaces. So for example, two towns might be 10 miles apart. That's your absolute distance. But if one has a highway and the other one has a winding dirt road, the relative distance is shorter for the first one, even though the miles are the same. So why does this matter? It helps explain how connected or accessible places are. It's important to understand migration, trade, and urban development. Here's a key point. Relative distance is about perception and experience, not just numbers on a map. It can change over time with new technologies, for example, trains or planes or infrastructures like bridges and tunnels. So in AP Hug, we talk about direction, and we talk about it being the direction telling us which way we're going to and from another place, which is kind of like what direction really means, but this is what we're going to look at. We look at it in terms of cardinal directions, north, south, east, west, or intermediate directions, northeast, northwest, southeast, southwest. So for example, if city A is northwest of city B, that tells us the general path you'd follow to get from B to A. Why does it matter? It helps describe spatial relationships between location, and it's important for navigation, map reading, and understanding migration or trade routes. Two terms we're also going to need to know in AP Hug is clustering and dispersal. We're going to start with clustering. Clustering means that people, buildings, or activities are grouped closely together in a specific area. So think about a big city like New York or Tokyo. In cities, you're going to find like high population density, lots of services, businesses, homes, transportation. They're all packed into one place. Why? Because people tend to settle near jobs, schools, and public services, and other people. Clustering is common when there are strong economic or social connections. So, for example, a tech cluster like Silicon Valley forms because companies benefit from being close to each other, sharing ideas, workers, resources. That's clustering in action. Now, second one we talk about is dispersal. This, on the other hand, is the opposite. It means people or activities are spread out across larger areas. This pattern is more common in rural areas where homes, farms, or businesses are spaced farther apart. You'll also see dispersal in places with natural barriers like mountains or deserts, or where people want more space and privacy. An example of dispersal is in agricultural regions, where large plots of land are needed for farming, so homes are therefore far apart. So why does it all matter? Well, understanding whether something is clustered or dispersed helps geographers figure out why people live where they do, how cities grow, or how resources are used. It also helps explain access to services, transportation, and even inequality in some areas. So the next time you look at a map, ask yourself, are the points bunched together? Clustering. Or are they spread far apart? Dispersal. Another important thing we need to learn in AP Hug is talking about elevation, which really just means how high a place is above sea level. It might seem like just a geography fact, but elevation actually affects a lot of human activity. So first, elevation impacts climate. As you go higher above sea level, temperatures usually get cooler. So a city that's 8,000 feet up in the mountains will be much colder than a city that's at sea level, even if they seem like they're close on the map. Elevation also influences agriculture. In high elevation areas, it might be too cold or the growing season might be too short for certain crops. That's why people often live and farm in lower elevation valleys where soil is fertile and the weather is more stable. So in terms of settlement patterns, most large cities are built in lower elevation. So areas like coastal plains or river valleys, where it's easier to build infrastructure, grow food, and transport goods. High elevation areas like mountain ranges tend to have fewer people because the challenges they pose are like steep land, cold temperatures, isolation. A great example is the Andes Mountains in South America. While some people do live in the highlands, most of the people live in the lower valleys where life is easier. So in AP Human Geo, when we talk about elevation, remember it affects temperature, agriculture, transportation, and where people choose to live. Something else you're going to need to know about an AP Hug is pattern distribution. So when we talk about pattern distribution, we're looking at how things are arranged on the Earth's surface. Are houses built in a straight line? Are stores spread out randomly? Do farms form a neat grid? That's what pattern distribution helps us figure out. There are a few common types of pattern distributions. We're going to start with linear. So the features are arranged in a straight line like houses along a road or towns along a river. The second one, circular. Features form a circle around a central point like homes around a park or a central well. Next one, random. There's no clear order. Things are spread out without a recognizable pattern like trees in a natural forest. And lastly, grid or rectangular. This is often seen in cities that use block systems like New York City. So studying these patterns helps geographers understand how and why people build, move, and live the way they do. It gives clues about transportation, land use, planning, and cultural influences. And that's your crash course on Unit 1.1, Introduction to Maps and Types of Maps. This was looking at the CED question from 1.1, identify types of maps, types of information presented in maps, and different kinds of spatial patterns and relationships portrayed in maps. I'll be covering more units soon, so don't forget to subscribe and hit that like button if you found this helpful. Drop me a comment if you have any questions or you want me to explain anything in more detail. I'll see you next time. Thanks for listening.